Hello everyone, welcome for this lecture. Today we are going to see the next theorem, that is Thevenin's theorem. Okay, let's start saying the statement of this. A statement is Thevenin's theorem states that any linear active network with two terminals can be replaced by equivalent circuit consisting of voltage same VTH in series with the resistance RTH. The voltage source VTH is open circuit voltage at the terminals, and the resistance RTH is the resistance of the network between the terminals with all independent sources turned off, or it is the ratio of open circuit voltage to the short circuit current at the terminals. Okay, so let's see what is the statement of this Thevenin's theorem. It states that any linear active network with two terminals can be replaced by very simple circuit. Okay, you can say that Thevenin's theorem states that any complicated network which are linear active network, okay, so that can be replaced by a simple circuit which consists of voltage source and internal resistance with this. Voltage source is represented by VTH and resistance or impedance can be represented by RTH and ZTH respectively. Okay, so this, now what is this? VTH can be calculated as the open circuit voltage, okay, between those two terminals, and RTH is the resistance of the network between the terminals. Okay, equivalent resistance between the terminals. Okay, let's see, let's take a proof of this. Consider this network, okay, which has a voltage source, and they have asked us to write Thevenin's equivalent circuit. Okay, equivalent circuit means it is the, this is your Thevenin's equivalent circuit, TEC, we can say that. Okay, this is any complicated network between the AB terminal. Okay, they have asked us to calculate or to draw the Thevenin's equivalent circuit between the terminal A and B. Okay, what we have to do is remove this, note down the A and B terminal and remove this resistance, that is RL, keep aside. Okay, then we'll have only these two terminals without this resistance, and then this complicated, any kind of a network, means that is how much maybe complicated it is, it should be a linear one. Okay, that circuit can be replaced by very simple network which consists of voltage source and internal resistance in series with that between those two terminals, and after that we have to replace this RL. Okay, now how to get this much, how to get this circuit we have to observe. Let's say first thing is we have to find out VTH and then we have to find out RTH. Okay, now to find out the VTH, so we have removed that RL and we have kept aside, and now we have voltage source and then resistance. So here we have two loops. Okay, so but in the second loop what we have is open circuit. Okay, that is the open circuit. So in the open circuit current will be 0 but voltage will be present. Okay, that we have to keep in mind. Therefore here only we can write in the second loop, since second loop is a open circuit, so I2 will be equal to 0. So what we can do is apply KVL for the first loop and then apply KVL for the second loop. We will get to know what is the voltage VTH is. Okay, so then what we can do is apply KVL for the first loop. We are very familiar with this. So if you are applying this in the first loop, I1 R1, okay, plus R3 into, here two currents are there, both are opposite direction, so we will be taking R3 into I1 minus I2. Okay, and then voltage source minus V equal to 0. Now we can take, see this I2 is 0. Okay, we have already seen, because the second second loop is a open circuit. Okay, therefore you can expand it and then you can substitute the value, or else here only you can substitute the value. Okay, then once we get simplify this, we get I1 equal to V divided by R1 plus R3. Okay, yes, once we got, and then we can apply KVL for the second loop. You can observe, we can apply a KVL for this, which is I2 R2, okay, plus okay, R3 into I2 minus I1, okay, minus VTH equal to 0. I2 to anyhow it is 0, and here also I2 is 0. Then what will be there? Minus R3 I1 minus VTH equal to 0. So VTH is equal to, what we can say is, minus sign you can remove outside, or it will be minus R3 into I1. So what we can do is, directly in the second loop, without applying the KVL and all, you can write, if you have such networks, when there is an open circuit, what we can write is VTH, or voltage across this terminal, VOC will be equal to, this is nothing but current through this resistance and resistance. So R3 into current flowing through that is nothing but your I1 only. Okay, whereas I2 is 0, so therefore VOC will be equal to I1 into R3. That's it. You can now onwards you can directly write this. Open circuit voltage will be equal to, see, observe in this, if it is short, then would have thought about this current, because the current flows in the closed circuit only. Then we can say VTH is equal to R3 into I1, where we know I1, substitute the value R3 into V divided by I1 plus R3. Okay, this is how we have calculated VTH. And next we are going to see to find the ZTH, or you can say RTH. Okay, so what we have to do is to find out the RTH in the circuit. So if we have voltage source, that has to be short circuited. If you have a current source, that has to be open circuited. Okay, now we have a voltage source, so this should be short circuited, and keep all the other resistance as it is. Now this is only a short circuited, so you have, this is the A and B terminal, you have to observe the circuit through this. How we have to observe? Take these two terminal, stretch, as I told you in the previous classes, you have to assume this circuit as your as a wires. Okay, when you are observing this circuit, when you are observing from this, it is A terminal and B terminal. Take the A terminal, okay, this is the A terminal, stretch it out. So this is one resistance, and there are two resistance which will be falling here, and then this is your B terminal, right? Hope you have got this, how to stretch this circuit. Okay, you have to assume these are all wires and stretch it neatly. So this terminal, if you stretch, it comes here, right? If you stretch like this, then these two resistance will be what? Observe, these two resistance will be in parallel. Okay, and the coming equivalent resistance will be in series with this R2. Therefore what we can write is R1 and R3 are in parallel, plus result, whatever result comes, that will be in series with the R2, that is equal to your RTH. So write RTH is properly. RTH is equal to R1 R3, parallel formula, R1 R3 divided by R1 plus R3 plus R2. Okay, Thevenin's equivalent circuit is what? So VTH and RTH. Okay, and then now you can substitute the values of VTH and RTH, what we have calculated over here. And then if you would like to calculate IL, or current flowing through any resistances between those two terminals which we had, now we have to substitute here. Okay, and then we have to say IL equal to VTH divided by RTH plus RL. Okay, so hope this is your Thevenin's equivalent circuit, as well as the current flowing through this RL. Next we'll be dealing with a simple numerical using Thevenin's theorem. Find current through 2 ohm resistance. Where is the 2 ohm resistance? Here. Okay, wherever they ask you to find out the current through or voltage across, what you have to do is remove that. Okay, remove this resistance and keep aside, and then whatever the remaining you have circuit, that you have to place, and then give a name for that A and B terminal. Between this and this there is a A and B terminal. Okay, now so this circuit, so there are two loops. You can take I1 and I2. So I2 will be 0 because open circuit, second loop is the open circuit, therefore I2 will be equal to 0. Then apply KVL for the first loop. Start from this minus 50 plus 5I1, okay, plus 20 I1 minus I2 equal to 0. So simplify this, it will be 25 I1 minus 20 I2 equal to 50. Since I2 equal to 0, 25 I1 equal to 50, so I1 will be equal to 2 ampere. Okay, once you have calculated I1, apply KVL for the second loop, that is this loop. We can directly write, as we have discussed in the proof, that VTH is equal to 20 ohm resistance and current flowing through that is nothing but your I1 only. Okay, since we know the current at 2 ampere, I1 is 2 ampere, which is 20 into 2, which will be 40 volts will be your VTH. Okay, and the next what we have to do is we have to find out the RTH. So when you are calculating the RTH, what we have to do is you have voltage source. Whenever you have voltage source, they should be short circuited. So other than that we not have anything. So there was a voltage source, so we have short circuited. And then you have a resistances. Okay, observe your circuit like this. Stretch this wire, and here one resistance. Stretch this wire, so these two resistances will be in parallel. Coming resultant will be in series with a 4 ohm. Therefore 5 and 20 are in parallel plus 4 ohm. Okay, then 5 into 20 divided by 5 plus 20 plus 4. So simplify this, you will get 8 ohm. Therefore you can place that Thevenin's equivalent circuit will be VTH and RTH between those two A and B terminals. So VTH is 40 volt, RTH is 8 ohm. So now what we are doing is, since they have asked us to calculate the current flowing through that 2 ohm, is nothing but your IL, or current through 2 ohm also you can call it. So now whichever you have cut that resistance, now you have to place here between those two terminals. Okay, now current flowing through that will be single voltage source, and there are two resistance in series. So apply Ohm's law. So voltage divided by resistance, VTH divided by 8 plus 2, so which is 10. So 40 divided by 10 will be 4 ampere will be flowing through that 2 ohm resistance. Okay, next we'll see the Thevenin's equivalent numerical will be discussing, which we have a dependent source. Let's find out the Thevenin's equivalent circuit at X and Y they have asked. So anything they may ask you, like current flowing through any resistance or voltage across that resistance, or like this only, find Thevenin's equivalent circuit at XY. Okay, now so this we have, remember one thing, there is a dependent source. Note down, if we have a dependent source, then RTH or ZTH cannot be calculated how we used to calculate in earlier cases. What we can do is, whenever we have a dependent source, okay, we have to find out VTH is nothing but open circuit voltage, and then we have to calculate short circuit current, and then ZTH, or you can say it is RTH, will be equal to voltage divided by current, that is open circuit voltage divided by short circuit current. You have to remember this thing. Okay, now we have to calculate VTH. Observe, so between this only they have said we need not to cut anything, because already there is nothing. We are supposed to calculate the Thevenin's equivalent circuit. In that we require voltage and we require a current, short circuit current. So this is open circuit voltage, and if you close this, that will be short circuit current between those two terminals. Okay, let's calculate for VTH. Apply KVL for the first loop. Okay, when you are applying, you can start with this 6I1 minus 2I plus 6, okay, plus 6I1 minus I2, okay, which is equal to 20. Okay, now what is this I we have to find out? Okay, 6I1 minus I2 equal to 20. So I is what? That we have to find out. So what we can do is to find out that I, okay, I is nothing but the current flowing through this. So take a point P, apply KCL at that point. So KCL if you are applying, okay, apply KCL at that point. So when you are applying KCL, okay, so I is entering. So I'll take a plus I. Next I2 is also entering, so plus I2, and I1 is leaving, so minus I1 equal to 0. And now what we can say is I will be equal to, you can simplify this and get the equation, that is I equal to I1 minus I2, but I2 equal to 0, so I equal to I1. Therefore wherever you have a I value, you can substitute I1. Therefore it will be 6I1 minus 2I1 plus 6I1 equal to 20. Okay, because I2 is 0 here. Next I1 will be 2 ampere. Okay, if you simplify this equation, you get I1 equal to 2 ampere. And then what we can do is VOC also you can write directly, as I said you, VTH will be or VOC will be equal to 6 ohm resistance into current flowing through that. That is 6 into I1, 6 into 2, which is 12 volts. Okay, and now as we said, we cannot calculate the ZTH directly or RTH directly. We have to calculate the short circuit current over here. So then what we have to do is short those two terminals and apply. So whichever method you can apply. You can apply your KVL or you can apply KCL method, node or mesh analysis, anything you can do, but we have to calculate what is this ISC. So to best easy way to calculate a current through this will be applying KVL, that is mesh analysis. Okay, apply KVL for the first loop, then it will be minus 20, 6I1 minus 2I plus 6. You are in the first loop, so I1 minus I2 will be equal to 0. You can simplify this equation since I2, so now I cannot say I2 is 0, remember. Okay, so I2 is the second loop current. So simplify this, you will get an equation, that is 10I1 minus 4I2 equal to 20. Let's call this equation number 1. Okay, so as I said you, how to calculate I over here. Okay, how to calculate I? Take a point P here. Okay, take a point P and then apply KCL over here. Then when you apply KCL, you can calculate what is the I is. So on the basis of that, you have to substitute here, right? And then apply KVL for the second loop. When you are applying KVL for the second loop, then it will be, you are in the second loop. Okay, 10I2, okay, plus 6 I2 minus I1 equal to 0, right? That is the equation. Okay, so see, if you simplify that, it will be minus 6I1 plus 16I2 equal to 0. So you have got two equation. One is 10I1 minus 4I2 equal to 20, and another one is minus 6I1 plus 16I2 equal to 0. Okay, when you have these two equations, okay, you can easily solve this. One is 10I1 minus 4I2 equal to 20. Okay, 10I1 minus 4I2 equal to 20, and another one is minus 6I1 plus 16I2 equal to 0. By simplifying those two equations, you get I1 some values, and we require I2, therefore we will be concentrating on I2 much. I2 will be equal to 0.8823 amperes. Because why we concentrating on only I2? Why I have not written I1? Because I don't require that I1 right now. Okay, I2 is nothing but your ISC. Okay, you can observe in this circuit, whatever loop current is flowing, I2 is nothing but your short circuit current. So that we can note down here. ISC will be equal to I2. Okay, that is 0.8823 ampere. Then what we have to do is RTH we have to calculate. RTH is equal to VOC or VTH divided by ISC. Okay, so both the values we know, substitute, and we will get the RTH, that is 13.6. Then we can write Thevenin's equivalent circuit will be this one. Okay, So if at all, if we have any resistance between those two terminal, say suppose R, if they have asked us to calculate what is the current flowing through this, then we would have calculated the current flowing through that resistance will be equal to VTH divided by RTH plus R. Okay, and if at all they ask you what is the voltage across, what is the voltage across this resistance, then would have written VR equal to current flowing through that, that is current, this current, because these two resistance are in series, so this current will be remains the same. So this resistance into that current flowing through that resistance and that resistance will be voltage across that particular resistance. Okay, this is when we have to calculate ISC when we have dependent source. Okay, thank you.